Good morning, students. In the previous lecture, we talked about the scales of measurement and we discussed nominal scale, ordinal scale, interval scale and ratio scale. The question arises why it is important for you to understand these four types of scales. The reason being, whenever as a researcher you are given any data to analyze, then for analysis purposes obviously you need to apply some statistical techniques. So you should be able to identify the data which is being given to you. It is asked on which scale, so that for the type of scale you can use the right statistical technique, right? So it's important for you to understand, because all the techniques cannot be applied to all the scales. Ratio scale is that scale on which you can apply all your statistical techniques. For nominal scales, the only technique which can be applied is counting. For other scales, you may apply median or mode. So you need to be very clear so that you apply right analysis technique to the right data and you are doing your analysis and interpretation in a proper manner. In your syllabus, we have three types of data analysis techniques: measures of central tendency, measures of dispersion, correlation and regression. So in this tutorial, I will be talking about measures of central tendency. Now, as the word suggests, central tendency. So by these statistical methods, we are trying to arrive at a central value which is representative of the entire data set. Say for example, I have the information with regards to the total marks which are obtained by a particular student of BAF in the semester and exams. So out of 700, I have the total marks obtained by each student. Now, if I need to report this details to a higher level officials, I obviously cannot report that roll number 1 scored 500 marks out of 700 or roll number 2 scored 600 marks out of 700. I need to represent that majority of the students scored 450 marks. I need a single value which could represent the total marks obtained by all the students of that. So that you call as average, or that you call as measure of central tendency. It's a single value within the range of the data that is used to represent all of the values in the series. Now, what are the objectives of doing averaging? Number one, to arrive at a single value, because no human being can memorize such a vast information. It is nearly impossible for me to memorize the marks obtained by every student of my class, right? So but obviously I can memorize an average figure. So that will be a single value which will be easier for me to memorize and report. Then getting bird eye view, obviously it will tell me where the class stands if I look at that single value, and I could be pretty much sure that if it is a central value, majority of the observations are revolving around that value. So say for example, if in a test, the test was of 50 marks, and if I calculate the average comes out to be 15 marks. So that 15 indicates that majority of the students have scored marks somewhere around 15. That could be lesser than 15, that could be higher than 15. So it indicates to me that the performance is not, because the total score was 50. But if I calculate the average, it is coming to be 15. So which is very less, not even 50% of the marks. Then next object of averaging is it helps you in tracing relationship between variables. Then last is knowing about the universe from sample. Whenever a researcher is doing a research, it rarely happens that the researcher goes in for a census survey. So obviously he draws the sample from the universe, and from that sample, if the question is asked on a ratio scale, supposingly the researcher asks the question age, so many respondents will give their answer to it. Now if the same type of research is done by another researcher and another sample is drawn, it should be giving the same results. So this you call as that from that sample you are trying to conclude about the entire universe. So that is also one of the important objectives of averaging. Then next comes is characteristics of a good measure of central tendency. So number one is it should be simple to calculate and easy to understand, because if the calculation is very rigorous and it requires a lot of effort, it may not be used by an ordinary researcher. Second comes it rigidly defined. Rigidly defined means that the formula which is used for calculating the average, that should be same whenever it is used by any researcher in and around the world. The reason for doing this is that because if the statistical average is not rigidly defined, then every researcher will devise their own formula, and due to which, even if the similar kind of sample is drawn from the population, results will not be same. So a good measure of central tendency should be rigidly defined. It should be based upon all the observation. So if there are 150 data sets in the data, then a good measure of central tendency should be based upon all the observation. Then it should not be affected by extreme values. Say for example, there are marks which are being scored by a particular class. The marks could be out of 75, 50, 40, and then on the other end there is 0. So which may significantly differ the average. So a good statistical measure of central tendency should not be affected by extreme values. Then it should be capable of further algebraic treatment. This means that on an average, we should be able to apply some other formula. Many of the averages are used for calculating weighted averages. Say for example, if I take the average of marks scored by girl students and if I take the average of marks scored by boy students, then I should be able to calculate their weighted average. So that is the perfect example of further algebraic treatment. It should have sampling stability. Sampling stability means that if different samples are drawn from the same population at different intervals of time, then the average which is being calculated from all those samples should not significantly differ. Then it should be easily computed in case of open end class intervals. Open end class intervals means supposingly in your questionnaire you put a question annual income, and one of the options you give, which is probably the last one, greater than 5 lakhs. Now this is an open end. 5 lakhs, the income could go be 1 crore, it could be 5 crores, it could be 7 lakhs. So a good measure of central tendency should be easily computed in case of open end class intervals. Then it should be in the form of a mathematical formula. So types of measures of central tendency, we have mathematical measures of central tendency as well as positional measures of central tendency. Positional, why these are being called as positional? Because they tell the position of the average in the entire data set. So number one, arithmetic mean, which is very simple and which is widely used. So it refers to the value which is obtained by dividing the sum of the values of all the items by total number of items. So I have the total marks of all 150 students of BCAF, and if I aggregate all those marks and divide that by 150, then I get the arithmetic mean. So this is the formula. X bar denotes the arithmetic mean. Summation. Xi means the marks which are being scored by observation. I is your observations and N is number of observations. The most simple mean. Merits and demerits of arithmetic mean, it's most popular. Whenever a layman talks about average, he or she is probably talking about arithmetic average only. Average age of a person is told as 60 years, many a time. So herein we are using this average word in day-to-day life. It is quicker and easier. It's very simple to calculate. It is rigidly defined because it has a mathematical formula which is used all over the world. It is based upon all the items because in the formula we are adding up all the observations. It can be used for calculating weighted averages. It helps in comparison. Say for example, in one period of time or in 1 year, I may see what was the average marks scored by the students in the year 2020 and what was the average marks of the students in the year 2019. So I can easily compare. Arrangement of order. In arithmetic mean, there is no need for arranging your series into ascending order or descending order, which may be required in other measures of central tendency. So I just take the observations as it is. I need not to arrange them in ascending order or descending order. Demerits absurd results. Say for example, we collect data with regards to the shoe size, and people will maybe responding 5, 6, 7, 3, 4. It may be possible that when you add up all these shoe sizes and divide by number of observations, the average could be in decimal, whereas shoe size is never in your decimal. So sometimes this arithmetic mean gives you absurd results, and it may give mean as such value which will be non-existent in your data. Then it is not suitable for incomplete data. If you do not have all the observations, you cannot calculate arithmetic mean. Arithmetic mean is also affected by presence of extreme values in the data. Then mean value may not be in the data, as I told you. Open and class intervals, it is very difficult to calculate arithmetic mean in case of open and class intervals, and it has a limited application because it cannot be computed here, and the mean value may not be in the data, and sometimes it gives you absurd results. It's very simple, but for layman's purposes it is quite used. Thank you.